welcome to SHS3 Integrated Science Revision Session. I am Esiama Kufuor. In this session, we'll be looking at candidates' responses. The lesson is designed to have studio students answer typical WASSCE examination questions and their responses analyzed, with comments explaining the strengths and weaknesses of their answers. That is, where and why marks were awarded, to help students interpret WAEC standard and help them refine their examination techniques. Let us begin by introducing our studio students. I'll begin from my immediate left.
Smith.
Letitia.
Godwin.
Ifwa.
Christian.
Okay. Now, let us go through the questions together. We begin with question A. What do you understand by the term isotopes? B. Complete the table to show the relative mass and relative charge of a proton, a neutron, and an electron. You are provided with a table with 3 columns. The first column with the heading particle, the second column with the heading relative mass, and the third column with the heading relative charge. You have been provided the relative mass of proton to be 1, the relative mass of electron to be 1 over 1,840, and you are expected to give the relative mass of neutron and the relative charges of proton, neutron, and electron. C. Consider the following chemical substance: phosphorus with left-hand superscript 31 and left-hand subscript 15 and a charge of -3, and complete the table on your screen. You are expected to give the total number of protons, the total number of neutrons, and the electron configuration. Then finally, you are expected to draw the structure of propene. Students, you have 10 minutes to answer the questions. You can now start. Stop work. Let me have the pictures. Now let us look at how Gordon could have improved his answer. Godwin, you should have stated that isotopes are atoms of the same element, having the same atomic number but different mass numbers. Or isotopes are atoms of the same element, having the same number of protons but different number of neutrons to score a full marks. So that is how you should have, answered your question. Yes.
Are isotopes not elements of the same atom? For example, elements carbon 12 and 14, not elements of the same atom carbon?
Not really. When we say isotopes, we mean atoms of the same element. Now, the element is defined by its atomic number. All elements have got a unique atomic number, and that is what makes them, that gives them their name. For example, you gave carbon 14 and carbon 12 as examples of isotopes. These are different atoms of the same element called carbon. It is called carbon because they have a unique atomic number. When we write them, we represent them as the number here indicates the atomic number. You will see that both of them have got a unique atomic number, and that is 6. That makes it, this one get its name as carbon. So these two are atoms of the same element called carbon, having a unique atomic number of 6, and not the other way around. They are not elements of the same carbon. If you say they are elements, that means they have different atomic numbers. But once the atomic numbers are the same, they are given one name, and that name is carbon. So isotopes are atoms of the same element, having the same atomic number, but different mass numbers.
Can an element have more than 2 isotopes?
Yes. The carbon that you gave as an example exists as 3. We have carbon 12, carbon 14, and another one which is C. And this is called carbon 13. So carbon has 3 isotopes. It's not only carbon that has 3 different isotopes. Hydrogen has hydrogen 1, hydrogen 2, and hydrogen 3. They are written as H11, H. They have the same atomic numbers, but their mass numbers are different. Is your question answered?
Yes, sir.
Yes. Now let's go to B. Godwin, you fail to appreciate that relative charges have values. And so proton, neutron, and electrons have relative charges of +1, 0, and -1 respectively. Yeah.
Is the charge of an electron negligible?
Oh, it is rather its relative mass that is negligible.
Okay.
Because it has a relative mass of 1 over 1,840. And if you evaluate this, you get 0.00. The answer, virtually is approximated to be equal to what? 0. And that is why they say it has negligible, relative mass. But as far as the charge is concerned, it has a relative charge, which is supposed to be -1. Now let's look at your response for C. You fail to appreciate that phosphide ion has the same atomic number as its what? Neutral atom. And that is supposed to be 15, which is the left-hand subscript value that was, there. Are you okay? And so the atomic number of the phosphide ion is the same as the atomic number of its neutral atom. Then, again, you also fail to apply the formula for finding the number of neutrons. That is, you have to subtract the number of protons from the mass number. In other words, the atomic number from the mass number to be able to get the number of neutrons. And when you do that, if you subtract 15 from 31, you are supposed to get 16. And so the number of neutron is 16. Then finally, for ions, the atomic number and the charge on the ion are used to determine the total number of electrons that will be available for you to write your electron configuration. And so, in this case, you were supposed to have 18 electrons to distribute into the various shells to write the electron configuration. Yes.
Kindly go over how you determined the electron configuration of an ion.
Okay.
I don't understand.
Okay. Now, the substance was represented as now for anions, the total number of electrons available is equal to the atomic number plus the number of electrons that has been gained, or the number of electrons gained. And so the total number of electrons in this case become 15 plus 3. And that will give us a total of 18 electrons. If the ion is a cation, then you determine the total number of electrons by subtracting the charge, that is number of electrons lost, from the atomic number. Then you have a total number of electrons left. And this figure is what you use to write the electron configuration. So for instance, if you take sodium plus, sodium has atomic number of what? 11. And so the total number of electrons left for sodium cation is going to be the atomic number, which is 11, minus the number of electrons lost, which is what? 1. And therefore, the total number of electrons become 10 electrons. So for anions, you need to add the total number of electrons gained to the atomic number. And for cations, you need to subtract the total number of electrons lost from the atomic number to get the number of electrons that you have to use to write the electron configuration. Have I made myself clear?
Yes, sir.
Very good. Finally, in D, you gave the chemical formula correctly, the correct chemical formula, but you should have proceeded to draw the structure because the question demanded the structure of the compound, and therefore you lost the marks. So you got the chemical formula of propane correctly, but the question asks for the structure.
Yes, sir. Is it not also right to represent propene as C3H6? And what will you call C3H6?
I'll call it propene, all right. But there are 3 ways of representing an organic compound. Organic compound can be represented with a molecular formula, what we call the condensed formula, and the structure, or the structural formula. And so for propene, you identify the molecular formula to be C3H6. This is supposed to be the molecular formula. The condensed formula could have been written as this. Are you with me? Then the structural formula is written. I'll put 2 bonds here, then put the hydrogen atoms as this. We term this molecular formula, that as condensed formula, and this as the structural formula. And this is what the question demanded. Yes.
I think.
Yeah, there's a hydrogen here. Thank you.
Well understood, sir.
Okay. So that is it for Godwin. Let us now move and analyze the response of Letitia. Letitia, you partially gave correct definition for isotope by stating that they are atoms of the same element, but failed to appreciate that they are made up of the same number of protons and not the same number of neutrons. You said they are made up of the same number of neutrons and different number of protons. You interchange them. And this is a misconception that students have been having. So you should have said that isotopes are atoms of the same element, having the same number of protons but different number of neutrons. It's the differences in number of neutrons that account for their differences in mass number. So that was what you were supposed to say to score the mark. Now in C, you got B correct. In C, you assume wrongly that the total number of electrons equal the number of protons in an ion. You fail to appreciate that atomic number of a proton, or the proton number of a neutral molecule and that of an ion are the same, because the total number of protons in a neutral molecule or in a neutral atom and an ion are the same. And therefore you should have, given the atomic number or the number of protons to be 15 instead.
Okay, so electrons were gained by phosphorus to acquire -3 charge.
Okay.
Should the atomic number not also be -3?
That sounds logical, but the electrons were added to the shell, the outermost shell. Are you with me?
Yeah.
Yeah. The number of protons did not increase. It is electrons that were gained. Are you okay? 3 electrons were gained. And the 3 electrons that were gained went into the outermost shell and not the nucleus. And therefore, it did not alter the total number of protons inside the nucleus. And that is why the atomic number remains as 15.
Okay.
Are you okay?
Yes, sir.
Very good. Now let's look at the last one, that is the D. You were able to deduce the correct molecular formula. You went ahead to draw the structure. You got the carbon chain correct, but the carbon atoms bearing the double bond had 5 bonds instead of 4. Carbon is a tetravalent element, and therefore the carbons bearing the double bond should have 4 bonds around them and not 5. And therefore it made your answer wrong. So you were supposed to remove 1 bond and the hydrogen from each carbon atom bearing the double bond to get the correct structure.
But please, can a student at least gain a half mark for stating or writing the correct period structure?
Unfortunately, science is a technical subject, and our rules have to be observed strictly. When you change or you misapply any of the rules, then you will get a structure which violates the very fundamentals of science. The figure that you have presented here, you have said the carbon bearing the double bond is pentavalent, which is not accepted in science. Yeah. So you need to apply the rules and apply them what? Strictly. If you omit a single word, or if you omit or you misapply any one of them, it will result in what? A wrong answer. So you need to apply them and apply them what? Strictly. Okay. Okay. So that brings us to the end of your response. Now let's look at Smith's response. Smith gave us correct response for all the questions, and therefore there isn't any question to be what? Analyzed. You did well, and you did an excellent work.
Studio candidates, thank you for your answers. Until we meet again, summarize your notes, go through the command terms usually used in WASI exams. Make sure you understand them. You understand the demands of each command term and apply them appropriately so that you will be able to avoid mistakes in your examination. We will meet again. Have a nice day.